Welcome to basic differentiation rules. So the idea here is so far we've seen the limit definition of the derivative, but that limit is not always pleasant to take, right? So using the limit definition of the derivative can get quite tedious. And so essentially what we want is shortcuts. Like we've seen that linear equations, the derivative is just the slope because a line has constant slope. That should be the derivative. So we would like to have sort of other rules we can use, right? And so we would like to have rules or shortcuts to find the derivative quickly. So first up is the constant rule. So if you think about a constant function is horizontal. That just has zero slope everywhere. So it makes sense that the derivative of a constant should just be zero. So the derivative, let me change colors for a moment. The derivative d dx of a constant c is just equal to zero. So in other words, if f of x is, say, 5, that's the constant function, then we have f prime of x is simply 0. Next rule is what is called the power rule. The power rule gives us a quick way to find the derivative if we have x raised to some power. So the derivative of x to the n winds up just being n times x to the n minus 1. This is, for now, for n, a positive integer. So for example, if f of x is equal to x to the 5th, then what we get is f prime of x is equal to 5x to the 4th. So the exponent comes out front and then we drop the power by 1. Next up, we have the scalar multiple rule. So if we wish to take the derivative of some number times a function, so c times f of x, this is just c times the derivative of f of x. Or c times f prime of x. So for example, if we wish to take the derivative of 3x to the 4th, this is the same thing as doing 3 times the derivative of x to the 4th, which then we could use the power rule to finish. So that would be 3 times 4x to the 3rd power, bring the 4 out front, drop the power by 1, or 12x cubed. Next up, we have the sum and difference rule. So what this says is we can split the derivative across addition and subtraction. So if we have the derivative of f of x plus or minus g of x, this is the same thing as the derivative of f of x plus or minus the derivative of g of x. Or in other words, f prime of x plus g prime of x, plus or minus. So for example, if we wish to take the derivative of x cubed plus 2x squared, we could separate this and take the derivatives individually. So we could do the derivative of x cubed and then the derivative of 2x squared. And by the power rule, we would have 3x squared. And then if we pull down the 2, we would have 2 times 2x, or 3x squared plus 4x. So as you can see kind of from the previous example, if we put all 4 of these rules together, that means that we can take the derivative of any polynomial we want. So just note, with these 4 rules, we can take the derivative of any polynomial function. And that is really nice because so far we've had to do the difference quotient and then take the limit. And if we had, say, a 6th power involved, we would have to do x plus h, take that whole thing to the 6th power, which would not be particularly pleasant. So now that we have the derivative rules, we can go ahead and skip the limit definition and just take the derivative of a polynomial using these rules. So in the next video, we will do some practice with that.